Welcome again to Data Analysis Basics. This is night 2 of our 3-night course or 3-day course, however you want to say it. So yesterday we talked all about data quality. Tonight what we're going to talk about, and let me just make sure that my mic is on correctly here so that you can hear me perfect. So tonight what we're going to talk about is data transformation. So yesterday we talked about quality. Tonight we're talking about transformation, and tomorrow at 6 p.m. Pacific time, we are going to talk all about visualization, presentation, facilitating. So what do you do with that data after you've done all of this work, after you've got all of this great information out of it? What do you do with it? So that's what we're going to talk about tomorrow night. If you haven't signed up for that yet, that's actually a Zoom link as well. So I'm going to post that in some of our groups. So make sure that you keep an eye out for that. That's also so that you can ask questions. So I'm doing these about 20 or 30-minute lessons for these 3 nights for my Lean Six Sigma newbies group. So if you're in that group, this is you that I'm focused on trying to provide value for you, trying to help you master some of these concepts. I'm Amanda Zimmerman. I am a Lean Six Sigma Master Black Belt, and I've been doing Lean Six Sigma for about a decade. I've been leading events maybe for 15 years, but in Lean Six Sigma, it's been about 10 years. Now, in that time, what I've seen is that so many people jump straight to, I need my green belt, I need my black belt, I'm going to be the top of the Lean Six Sigma continuous improvement certification, but they haven't mastered the basic concepts. So what I want to do is try to make those concepts really easy, try to make them accessible so that you can make sure that your projects are more effective, your projects are more successful. You're able to explain the concepts and teach the concepts better. Because let's be honest, this is like a train the trainer situation. If you are exercising Lean Six Sigma tools, you're working with a team. You should be working with a team. If you don't know how to facilitate and lead those projects, to teach those tools, it's going to be challenging for you to see the benefits of those projects. So I want to make those tools as easy as possible for you. So tonight we're talking about data transformation. Let me go ahead and share my screen here. So yesterday we mentioned this really simple definition of data analysis, that it is the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and support decision making. And as I said, today we're talking about that transformation piece. So that's what we're going to be focused on tonight. If you have a data set, go grab it, have it next to you. Think about it as we go through these activities. Now, tonight we're going to be really focused on using Excel. Excel's just one of dozens and dozens of tools out there. However, most Excel tricks translate fairly easily into other types of software. If there is a particular type of software we're keen on using, pop it in the comments there. That's something that next time I can use that to give the demonstration on. Tonight, I kind of pulled out some of the words that come to me when I think of data transformation. So we have normalize, standardize, consolidate, expand. These are all things that we're doing with our data as we're doing these analyses. Now, what I see us do when we have this data set, let's look at it this way so you can see a little bit more clearly what I have in here. Okay, so what we generally see is you have a problem that you're trying to solve. You have a Lean Six Sigma project that you want to move forward. And there's people out there who are collecting all kinds of information, right? We have probably operations, sometimes you might have marketing or call centers, we all have different departments. So all these people are gathering this data. Now, they don't know that you're going to use it for this project eventually, so it's just something that happens. They're collecting this data. That data is going to be in some kind of a database, in some kind of software, in some kind of table somewhere in your business. Now, for your project, you're going to request that data. So that data might come from multiple sources. It might have been collected by multiple different people. This is something to consider as we think about the steps that we might need to take as we transform our data, because we might be joining different data sets together. We might be joining data from people that don't talk to each other, from people that don't have a lot of communication, right? So that's really what we're talking about today, is all of that data coming together, and for you to be able to prep it so that you can do your analysis, your statistical analysis, your visualizations, and eventually communicate that, present that to your management team, present that to your Lean Six Sigma team, present that to the people who you're working on the project with. So there's a few different things that we're generally doing. Like I said, joining these different data tables. So some of the things that we might need to do is standardize. So ensure all of these different data points adhere to some standard. So let's say for that one, let's say one person collected that data in minutes while another person collected that data in hours, right? So you would have to adjust that so that you're using that same standard of either minutes or hours. The other thing that we might do is normalize our data. So this is something I see quite frequently, where we have data that are on different scales, right? So maybe one person is tracking cost per entree, just in general for the restaurant. Let's say if we were talking about a restaurant, one person might be doing cost per entree, another person might be collecting data that says cost per person per entree, and someone else might have the total bill cost plus the number of people at that table, right? So you need to normalize that. What is it that you want to see? Do you want to see the cost per table per week, per month, right? You need to normalize that in some way so that you're looking apples to apples, not apples to oranges or bananas, right? So that's normalizing our data. And we're going to take a look at, in just a few seconds, a spreadsheet that's going to help kind of illuminate some of these different items where they seem to me a little too squishy when we look at them this way. Consolidate. So one of the things that you'll be doing is you might see places where you have multiple columns, but you want to put this data into some kind of visualization, which a graph, a picture, right? You want to be able to see this data on a graph, which means that you have to take these different columns and you might have to consolidate them into one. Now, this can take a lot of work depending on what type of data is in there, and we'll look at a few of those examples. The other thing you might have to do, which I would say actually happens most frequently and is the one on all of this that I spend the most time on, is expand your data. So maybe you have one column where you need to actually break that into a few other columns, right? So this is one that we're going to take a look at as well. So let's go ahead and take a look at a data set. So here's a data set that we have. And let's just zoom in a little so that you can see it as much as possible. Okay, so here's a data set that we have in Excel. So you can see here there's a date that they received this. There's a purchase order number. There's some kind of part number or description of the part that was ordered. There's who purchased it. And then there's some kind of an error message. So maybe this kind of indicates some delay or reason that there was a problem. And then we have the completion date. So I wrote over here what the problem is that the team wanted to solve. So the problem was that they had the days from the date order was received to the date the order was completed is too high. So they want to reduce that. They want to reduce the days it takes from the order being received at the warehouse to when the person that ordered it actually receives it, right? Now, if we look at this data, we can see the date received, we can see the date complete. But if you were going to put this on a graph, could you see the cycle time? Could you see the number of days between date ordered and date received? Right now you can't, right? Right now you can't see that. So one of the things that you'll need to add, so one of the things that you'll probably want to add, let me actually put it over here. That looks a little bit better. Okay, so the first thing that you want to add is you want to know how many days did it actually take, because that's what you want to reduce, right? That's what you might want to do averages on, median, mean, mode, right? That's what you want to do. Look at the standard deviation. So let's say days to deliver item. Okay, and if we look at some of our formulas here, we can do equals this date minus this date. And that gives us 415 days, right? So that gives us some idea now of how long that's taking. Now, I don't know how proficient you are with Excel, but some of the tricks that you can do is when you see that black cross there, you can double click and that will take it all the way down for you. So now that number has been taken all the way down. Now, yesterday we talked about cleansing our data, and there's a few things here that might make our data messy. And you might have already seen that when we did that drop down. We now have these negative 42,775. Well, I'm going to guess we don't want those. So we can take a look here and we can take a look at those blanks that are causing that. And we're going to go ahead and delete this because that's data that's not going to be value added. Okay, so we've done one thing here. We've added a measure here that we might want to look at further later on. Another thing that we can do is, let's see, I put a little cheat sheet here. Can we review data? So let's take a look at this one here. This is what I mean by that. So let's say I wanted to do some of those summaries I just talked about. So we just talked about the days to deliver an item. But what I want to see is, like, does that change over time? So if I look at my average per week or average per day, does that change, or am I going to look at each of these as individual data points? Now, the first thing that I would probably do if this was my data set is I would want to see some of this data on a run chart, just to get an idea of how it is performing, if there's anything kind of weird in there. And so I can do something like this, where I can see that. That's not a run chart, but let's go ahead. You can choose change chart type, and we can go to a line. Okay, so then we can see kind of these different jumps here. You see there's a really weird data point we probably want to address there. The blanks are causing some weird stuff, but we can also see that it used to be much higher, and it seems to have come down. So it's a little lower than it used to be. But at the same time, the ones that don't have a delivery date, what if those ones are valid? So that could be something that we need to research more on. So this is something that just right away we can see some information, but there's bigger trends here that we can't really visualize. So what I would do is I would want to see that in a pivot table and with some summaries. But depending on the version of Excel you have, some other challenges you might have, the easiest way that you might have to do that, sometimes Excel will do this for you, but if that's not an option, I'm going to use the month and year from the date it was ordered. Oh, let's see. Oh, let me put, so equals year, open parentheses, and I'm going to go to that date received. Shouldn't we use, workday? Let's see. So if we use workday, in what column? In what column should we use workday? Okay, so let me better format month here, and maybe that's where you're mentioning that we could use workday. I haven't used that formula, workday. So I don't know the challenges of that one. Oh, this is why it didn't format correctly, because I didn't put month. Okay. So we've got that there now. We have our month, we have our year. So now what we can do is we can insert a pivot table, and we can see some of these summaries. So here we could see really quick the days to delivery. Now, when you first do your pivot table, you see here it says count. So we want to change that. Let's say for us, we're going to look at the average. You can see here there's some places where we don't have the right values. So we have some cleaning up of our data that we still need to do. But these are some of the things that we'll need to do to days to deliver. It omits weekends. Okay, that would be good. One of the questions I would want to ask if we do that workday formula is, are we working on the weekends or not? That would be an important thing. So if we're not working on a weekend, then that workday would be a great one to use because it would omit the weekends. So let's take a look though at one more thing that I want to highlight from this spreadsheet. So what we've done so far is we've added a summary column. We've expanded month and year so that we can do maybe some pivot tables or other types of analysis. And then we also have here that we haven't looked at is the error message. So when we look at our process performance, this is something we can use days to deliver item to look at our process performance. How is it performing over time? What is our baseline? But when we want to actually look at those errors, why things took so long, what we want to do is to be able to look at this really easy, maybe even put it into a Pareto chart or something, right? So that we can really analyze what's the most common issue that causes things to be delayed. So if we look at this spreadsheet where I've already cleaned it up a bit, we have here where I've put in first why or error message. So I cleaned up all of these error messages so that they are standardized, right? And this is something that really happens quite a bit. And we talked yesterday about cleaning our data, inspecting our data. And this is one of the things that we might have to do to make sure our data is something that we can use, right? And then we could put that into a Pareto chart and do further analysis. We could do other types of analysis on it, but with it being so all over the place here, right? Batch number, stock dimension batch, no batch number, batch dimension, right? With these being so all over the place, we can't easily see that that's the issue, right? It would be hard to see that in a visualization or in a pivot table. So we would want to clean that up like we have done here. Now, I want to give us one more spreadsheet example before we kind of move on and talk a little bit more about the formulas that I've talked about already. So let me zoom in here a little bit. So this is just a basic time study that I did. So I went out and I watched someone for several days do their job, or different people. I think there's 3 different shifts that I watched here. So we have Brittany, JC, and Sam that we did this observation with. So we got there in the morning and we did this observation. We sat down with them and we noted each time that each of these steps started. We also noted if this step was value added or non-value added, and if it was non-value added, we added the type of non-value added waste. Now, this is very cute. This is very good information, but it's not very accessible. Like, I can't show this to a management team. I can't show this to the person I observe and have them within seconds understand what's going on here, right? We can't really quickly see, okay, there's a lot of transportation, there's a lot of defects, but minutes wise, does that matter? Is it very much, right? So what we want to do is we want to make this data table ready for that. And what we can do, first we have time like we did before, but we don't have the minutes, let's say minutes per task, right? We don't have the minutes per task. Now, what I do when I do an observation is I just put the time each task starts, because I know I can subtract. I know that I can subtract from each of them so that I can get that cycle time, that minutes or seconds that I'm looking for. And so if we look here on the observation data, we can see some of that. We can see that cycle time. Sorry, I was just waiting for a call there and it looks like I missed a call. Okay, so we can look at that cycle time here, and you can see really clearly here how many minutes per. Now, the other thing that we have is value added and non-value added are in 2 different columns when we originally got that data set. Okay, well, that's great. That happens all the time, especially when we're doing like a checklist or something that we're kind of doing observation data. But if we're going to put that into a visualization, and particularly if you do the ghost charts and ghost tables that we talked about yesterday, if you want to make a visualization and you already know what you want to build, for me, I already know what I want to build, and I know that I need that value added and non-value added. I want them in the same graph. I want them in that same visual, which means I need them in the same column. So what I've done here is, if it was non-value added, I didn't write non-value added. I just put the waste down, right? So I consolidated that column into one. And then I could use a pivot table to really easily see the summary of that data set. So see how much time was adding value, how much time was not adding value, so that I could see some of our most common forms of waste. Now I can always double click on this, or double click here, and see that data, right? Get to see kind of what is that data, where did that data come from, what were the data points that made up that excess motion, right? So this really quickly now, I can see what's going on with my data because I've organized it in a way that I can do the visualizations that I want. I've transformed it to be able to do those analyses, right? So that's a really important skill for you to develop. I want to highlight here, because I am sharing this in a way that I'm focused on people that might be new to data analysis, new to looking at these spreadsheets. So I want to talk a little bit about the formulas that I just kind of breezed through, right? That these are things that we use really frequently in Lean Six Sigma or continuous improvement. And not everybody has access to kind of fancier tools. So let's talk about filters. So I used filters in several places in these data sheets. I didn't even talk about it, but I did talk about it yesterday. So you can insert here a filter. So you can see here this little drop down here, but we want it for all. You can see when we added those columns, it didn't include it. So we can unclick filter, click it again. Now we have a filter on all of our data. And you can see as I used it before, I can go through here now and I can really easily take out blanks, right? I can filter that out of my data. Now there are some pros and cons to using filters. So let's talk about some of the things that we want to use it for. So have all of your information in the header. So when you use filters, make sure that you don't have like merge cells or multiple lines of headers. Make sure that each of your headers has a title in it, so text in it, so that you can see what's in that column below it. You want to make sure that that filter covers the entire table. So that's just like what we talked about there, where it had missed that last column. And then you want to make sure that when you're using those filtering options, that you're paying attention to what you're clicking and unclicking. Yesterday, we mentioned using Excel tables with cleaning and inspecting our data. So you can see here, I didn't do that today, which I think was one of the reasons my data here, I'm disappointed in it. One, it's so colorful. It doesn't need to be this colorful. But if we want to insert table and we want to make our table formatted, let's get it so the text all looks normal here. So if we wanted to get it formatted in an Excel table, this makes it much easier for us to do kind of the next things that we want to do in our pivot tables. But it also automatically does some of this stuff for us. So now we automatically have some of these filters. We automatically have some of this formatting cleaned up, right? So there's a big benefit to using that filter or the Excel named tables, the tables. Okay, the don'ts. Don't use for unformatted tables with a lot of blank rows. So if you're trying to use a filter and you have a lot of blanks and you have maybe a blank that actually covers an entire row. So sometimes what I see is we do like, we stack our data sets. So rather than having like one table of data with headers, we'll have one, and then we'll have another data table with headers, another data table with headers, and we'll want to filter all of that. Well, that's not going to work, right? If you have blank lines, if you have other headers below that main filter line, that doesn't work. That turns out really not the best. So you don't want to use it in that way. You probably want to actually take those bottom, like if you have several tables like that you've exported, you want to see how you could consolidate that in one table so that you only had one set of headers, which means you might have to add columns to indicate those different types of data points. Highlight large portions of the table when you can just select the top left cell. So sometimes we have hundreds of columns or hundreds and thousands of lines of data. Look, if you're going to be selecting this and dragging it down for the next 10 years, oh my gosh, it's not necessary. In your table, you should be able to click that top right or top left cell and click on that filter, and it should put that filter on your entire header, right? So whatever your header row is, choose that left cell, and it's going to put that filter across the whole thing. Don't do the drag down for the next 10 years. That's not necessary. And so the other thing that's just cautionary is if you don't want your rows reorganized, don't use a filter. It's going to reorganize your rows. So if you have little comments off to the side, if you have a lot of weird stuff going on in your spreadsheet, don't use filters. It's going to confuse it, right? Because it also allows you to sort it and move around your lines. So that can create a lot of havoc in some of our spreadsheets. Now, this is one that's a great tip, especially if like in this spreadsheet that we took a look at. Okay, so we looked at this spreadsheet and we said that we have all these error messages, but all these error messages are weird and different. Well, that's a pain in the tush for you. And every time you export this data, it's a pain in the tush for you to try to clean that up. So what you should try to do is go to the source and make sure that that's not happening anymore. So if this is being tracked, let's say this specific spreadsheet is actually being tracked in Excel and people are typing this in to their Excel spreadsheet, they don't need to be typing in this in 18 different ways. We can make this so that they can only choose to type it in specific ways. So if we grab all of this data, let's go ahead and take a look at some of the things that we can do. Okay, so we're going to grab all of this. We're going to paste it into a random spreadsheet. So we added a new tab there. All right, so we're going to go to data and we're going to remove duplicates. So we're going to get a list of everything that was there, but only once because we don't need it 800 times. So 163 unique values. Yeesh. So we see here a batch number written 3 different ways, right? Which we don't want. We want batch number. Let's say we just want batch number. We want C of C. We want incorrect. Well, that's C of C. Let's see. Let's grab 2 or 3 more. We have some version issues. We have some stock dimension batch issues. So let's say, oh, and wrong PO number. That's a good one. So let's say actually when we look at those 163 different items, they're actually just these 5 different topics in different ways that we can say these same 5 things. Now you think that that's crazy, but you'll see this more frequently than you think, I promise you. So what we can do is we can create drop downs. We can make it really easy for people to choose the right thing because they'll only be able to choose the right thing. Now, if you've made this into a table, it makes it that much easier because it's always going to carry down that drop down. Otherwise, you're going to have to go in here and you're going to have to select, let's say if you know they're going to continue down this spreadsheet, then you might need to select the entire column, or you might want to select the next 100 cells. And what we're going to do to get that drop down working is we're going to go into data validation. And it's going to say allow. We are going to say list. There it is, list. Source, we're going to go back to that drop down that we just created. We're going to select those items. Okay. Now, anytime we do this new entry, I can only choose things that are in that drop down. Keep a backup before beginning. I just saw that comment there. Yes, it's always good to have a backup before we start changing our data. So if this is the data set people are inputting data into, definitely save a backup before you go in and you start making major changes. Especially, you definitely want to always keep a backup if you're going to try to write over these, right? So we've got all of these different reasons here, all of these error messages. So if we want to standardize batch, and you decide you're going to standardize this one and you're just going to copy it like that, you want a copy of that data so that in case you've copied over something that's not correct or you've made a mistake, that you can go back to that original data set. So let's see here. We were talking about data validation. So that gives you those drop downs so that you can use those drop downs so that you don't have to keep trying to go through all of this data to clean it up and inspect it, right? But that also makes it really easy for you to do things like Pareto charts, right? To do other types of summaries so that you can see what is the issue that's coming up most frequently? What is the failure that's contributing to the most cycle time, that's taking the longest, right? Now, you want to make sure that you make the options relevant to the user, the person using it. Sometimes I see when we create drop downs or other activities like this, we care more about what we need from it than actually the person that's going to be using it. So you really need to talk to the person using it and ask them, what do they want? What do they like? I would give a rule of thumb that I prefer drop downs that are 10 items or less. So obviously, if you're doing states or counties or countries, you know, those have a set number of items. If you're doing reasons why something failed, I would generally try to stick to something that's in that 10 range. When we go over that, it starts to become so diluted that it makes it hard for us to make decisions off of. So that's why I'll often do, as you may have seen in this spreadsheet, let's see here on the final one, first error message. First Y error message. So what I'll do is a first Y column, a second Y column, but I try to limit the number of options people have for each one because otherwise it does get a bit crazy. The other thing that really happens quite frequently when we do these drop downs is that people want to add to the drop down. And so they put things here to add to the drop down, but that won't actually add to it. So to actually add to the drop down, you either have to, you can add data like this, but then you have to go back and do the data validation step again, like we did before, or you can insert. So if you insert here, example, we can go back to wherever we created this. And now example is one of the options, right? So that's a bit of a hack there for when we use data validation. And then I'm just going to go over one more of these with you, and that's if statements. So if you haven't used these yet, this is something that in your Lean Six Sigma career, if you're using Excel a lot, this is going to be the greatest. This for me is probably what I use most frequently when I'm analyzing data, when I'm transforming my data to make sure that I can easily take that and put it into a table. So those if statements, what that does is the first thing is you're going to be some kind of a test. So do these two items equal each other? Is this item a blank? And then you're going to have what the result is if it's true, if that test is true, if the two items do equal each other in this example, and what the value is if it's false. So if these two items don't equal each other, what do you do? This is something that we use really, really frequently when especially we're joining data. At least in my experience, when I join data, I end up using these if statements quite a bit to see if my two spreadsheets really are, maybe I'm taking two different queries and they're supposed to be exactly the same, and I want to see if they are. And so I can take two cells that should be the same. I can run that if statement down the two columns and I can compare, are they actually the same? And that can tell me really quickly if I have any errors or problems. Now, we use this for all kinds of things, all kinds of decisions and calculations you can use this if statement for. So I really encourage you to play with this. And this is something, if people are interested in learning more about if statements, that we can talk about more. But this is something that comes up quite frequently. So it is something that we end up having to kind of lean on quite frequently. So I hope you enjoyed our presentation today, our data analysis basics. I'm super excited to be able to share with you, trying to keep things as simple as possible as we talk about data transformation, data analysis. Tomorrow, we're going to talk more about taking this data that we've now transformed, that we've now cleaned up, that we're putting into visualizations, and taking that and creating visualizations that are powerful, that people can understand, and that you can present to management. So I will be sending out that Zoom link to people who have registered. Otherwise, it will be available in the groups. So make sure that you keep an eye out on that. That's definitely because I want to make sure that I answer your questions so that you can actually ask those to me one-on-one tomorrow night when we talk about that. Now, I really want to make sure that you understand how important it is that once you've done these steps, you can communicate this information to your management team or to your team that you're working with. Because if you can't, or if you haven't done a good job on the analysis, on the quality and the transformation, then it will be revealed by your management team. It will be revealed by your team. They are going to ask you questions that you're not going to be able to answer, or when you answer them, it reveals that there's a gap. So I think somebody mentioned, I don't know if it was in this group or another one, that you can tell sometimes that it's fake data because everything ends in a 0 or a 5. You know, that's something that's a tell. How come all of your data is within 5 minutes? Did they really note it down by the minute? That doesn't seem right. Why were they, rounding up or rounding down, right? So things like that come out at these meetings. And we want to make sure that you can communicate this stuff as easily as possible, as simply as possible, so that you rock your next event, so that you are awesome in your next continuous improvement event, which is what all of this is about. Thank you so much for joining me tonight, and I look forward to seeing you again